This is the second part of chapter 7 on study of gas laws. We had seen Boyle's law in the previous class. The second law is called Charles's law. Okay. Now, in Boyle's law, there was one quantity which was constant, that was temperature. Okay. If temperature is constant, then the volume and pressure are inversely proportional to each other. Okay. That was Boyle's law. And Charles's law, pressure remaining constant. In this case, pressure is going to be constant. Pressure is not going to change. Okay. The volume of a given mass of dry gas is directly proportional to its absolute temperature. Okay. Pressure is going to be constant and the volume of a gas is directly proportional to its absolute temperature. Volume is going to be directly proportional to temperature. Okay. So volume is directly proportional to temperature. Pressure remaining constant. Okay. Now, it's directly proportional. In the previous case, it was inversely proportional. So, proportionality sign was there and volume and pressure was inversely proportional. So, volume was in the numerator, pressure was in the denominator, 1 by P. Okay. So, that is inversely proportional. Here, volume is in the numerator, temperature is also in the numerator. Okay. In that case, this proportionality is directly proportional. Means, if you increase the volume, temperature also will increase. If you decrease the volume, temperature will also decrease. Okay. So, directly proportional. Means, if volume increases, temperature increases. If volume decreases, temperature also decreases. Okay. Whatever is the change here, the same change happens here. That is, if you increase the volume, temperature increases. If you decrease the volume, temperature also decreases. Okay. So that is why it is directly proportional. Okay. So volume and temperature are directly proportional here. Now if I remove this proportionality sign and put an equal to sign, as I told you previously, whenever you remove the proportionality sign and introduce an equal to sign, you have to introduce a constant. So V is here, this is going to change to equal to, T is here, because this changed to equal to, you introduce a constant. Constant is K. Bring the T this side. V divided by T is equal to a constant. If you divide volume and temperature in any condition, okay, then it always remains a constant. Okay. So, according to Charles' law, this is Charles' law equation. If I take in one place, the volume is V1 and temperature is T1, and another place, volume is V2 and temperature is T2. If you divide volume and temperature, it will always remain a constant. That is V1 by T1, this is in the first place, okay, is equal to V2 by T2, this is in a place which is different. Okay. If you divide volume and temperature, in both cases, both values will be the same. That is why I have written equal to a constant K. Okay. So this is Charles's equation. Okay. V1 by T1 is equal to V2 by T2. Using this Charles's equation, we are going to do a few questions. Question number 7. It is required to reduce the volume of a gas by 20% by compressing it at a constant pressure. To do so, the gas has to be cooled. If the gas attains a final temperature of 157 degrees Celsius, find the initial temperature of the gas. What is going to be constant is here. The pressure is constant. So pressure is not going to change. It's only related to volume and temperature. Okay. So it says it is required to reduce the volume of a gas by 20%. Okay. By compressing it at a constant pressure. To do so, the gas has to be cooled. If the gas attains a final temperature at the end is so much, 157 degrees Celsius. Find the initial temperature of the gas. Okay. So two cases again, initial and final. If you read this, final temperature of 157, final temperature, that is T2, is 157 degrees Celsius. It is in degrees Celsius, you have to change it to Kelvin. So 157 plus 273, that will give you 430 Kelvin. Okay. Now, it is required to reduce the volume of the gas by 20%. Okay. Now, initial temperature, you don't know, that's what is asked. Find the initial temperature of the gas. Initial temperature T1 is a question mark, you don't know. Okay. You don't know the initial volume also. Nowhere it is mentioned any volume. Okay. So what we will do is, we will consider volume 1, initial volume is V1 itself. Okay. No need to put any other variable, you can use the same variable. Okay. Initial volume is V1. Okay. It says it is required to reduce the volume of the gas by 20%. If I say in your exam, out of 100 marks, that's 100%. Okay. I reduced your marks by 20%. Means you will be getting 80% marks. Okay. The exam was for 100%. Okay. Percentage of marks is 100. So 100%. And if I say I reduced your marks by 20%, means I subtracted 20 from the 100, which means you are going to get only 80%. Here it says volume of the gas is reduced by 20%. By 20% it is reduced, which means from 100%, 20% is deducted or reduced, it becomes 80%. So, second volume, volume 2 is 20% is reduced, means it becomes 80%. 80% if you have to write, that is 80 by 100 of its initial volume. Of initial volume is V1. It was reduced by 20%, which means it becomes 80%. 80% is 80 by 100 of its initial volume. Initial volume is V1. Okay. So these are the things that you know. Let's see the calculation. According to Charles's equation, okay, V1 by T1 is equal to V2 by T2. Substitute the values. V1 is V1 itself, by T1 you don't know, so T1 is equal to V2 is 80 by 100 into V1 divided by T2's value is 430. Okay. So, to simplify, look at this one. You can cancel few things. Okay. That is, this V1 and this V1 gets cancelled. You can cancel 1 0 here, 1 0 here. Take this T1 that side, it goes as T1 on this side, and shift all these numbers to the left hand side. So the 100 comes here, okay, and the 43 comes here, that's 43 into 100, these two are here, divided by 8. Okay. Again, both can be divided, 8 can be divided by 4 twice, 100 can be divided by 4 25 times. Multiply these two and divide by 2, you will get 537.5. Okay, this is the answer that you will get by simplifying this, 537.5. Now, going back to the data that you wrote, temperature in the second case was in Kelvin, which means temperature that you are going to get in the first case will also be in Kelvin. So, that's 537.5 Kelvin, because previous one also was in Kelvin. That is the initial temperature. But if you look at the question, the temperature that was given was in degrees Celsius. So you can convert it to degrees Celsius. So you got 537.5 Kelvin. If you have to change Kelvin to degrees Celsius, then 537.5, from that you subtract 273, that will give you 264.5 degrees Celsius is the initial temperature. Next, there are a few things that you have to know. If you look at the Charles' law's statement, that's this. It says pressure remaining constant, the volume of given mass of dry gas is directly proportional to its absolute temperature. Okay. Absolute temperature or otherwise called Kelvin temperature. The volume is directly proportional to its Kelvin temperature. Okay. Not temperature in degrees Celsius. Okay. Volume of the gas is directly proportional to the temperature in Kelvin. Okay. So, an absolute scale also means a Kelvin scale. Okay. Absolute scale also means Kelvin scale. And absolute zero also means Kelvin zero. Kelvin zero means 0 Kelvin. Okay. So 0 Kelvin is called Kelvin zero, otherwise called absolute zero. Okay. And the scale that you are going to measure Kelvin is called Kelvin scale, otherwise called absolute scale. Okay. Now, if I take this Kelvin zero, which is 0 Kelvin, it is equal to, if you have to change Kelvin to degrees Celsius, you have to subtract 273. So 0 is the value minus 273. I am going to change it to degrees Celsius. So if you subtract this, you will get minus 273 degrees Celsius. So Kelvin 0, which is 0 Kelvin, is also minus 273 degrees Celsius. Then, few other things that you have to know is about STP or otherwise called NTP. STP stands for standard temperature and pressure, or normal temperature and pressure. Okay. STP stands for standard temperature and pressure. Okay. Now, what is the standard temperature and pressure? Okay. So you have to know what is the standard temperature and what is the standard pressure. Okay. Coming to standard temperature, a standard temperature is 0 degrees Celsius. Okay. This is the standard temperature. If I say a gas has a temperature of something at STP, okay. If it is at STP, it is the standard temperature, which is 0 degrees Celsius, or if you have to change degrees Celsius to Kelvin, add 273 to this, that will be 0 plus 273, that's 273 Kelvin. Okay. So standard temperature is 0 degrees Celsius or 273 Kelvin. Okay. Similarly, the standard pressure is 760 millimeters of mercury. If it is in millimeter, it's 760, and if it is in centimeter, it is 76. 760 millimeters of mercury or 76 centimeter of mercury, or it can also be 1 atmos. This is your standard pressure. So if something is said to be at STP, then you should know that the temperature is 0 degrees Celsius or 273 Kelvin, and if it is at STP, means the standard pressure is either 760 millimeters of mercury or 76 centimeter of mercury, or it can be 1 atmos. So these values also you have to know. The last thing is about gas equation. Gas equation is a combination of the two laws or the two equations which you got from the two laws. The first law is Boyle's law and the second one is Charles' law. The gas equation that is here is got from the combination of these two laws. So on combining Boyle's law and Charles' law, we get PV by T is equal to a constant. If you think of only Boyle's law says P into V is equal to a constant. Okay. Only that much. P into V is a constant. And Charles' law says V by T is a constant. There is no pressure. Pressure is constant there. Okay. V by T is a constant. So combining them, the equation that you get is called gas equation, which is PV by T is a constant. So if I take pressure, volume and temperature in two different places, in the classroom the pressure was P1, volume was V1, temperature is T1. And in some other place, the pressure was P2, volume is V2 and temperature is T2. Okay. Then, if you put those values in this, it will always remain constant. So, gas equation is P1 V1 by T1. According to this, P1 V1 by T1 will be equal to, for the second place, P2 V2 by T2. P1 V1 by T1 is equal to P2 V2 by T2. You can go on, equal to, if there is a third place, then it will be P3 V3 by T3. If there is a fourth place, is equal to P4 V4 by T4 and so on. It will always remain constant. So this equation is called gas equation. Using the gas equation, there are two questions which you are going to solve. The first one is question number 3. A fixed mass of a gas has a volume of 750 cc at minus 23 degrees Celsius and 800 millimeter pressure. Calculate the pressure for which its volume will be 720 cc, the temperature being minus 3 degrees Celsius. Initially, the volume is 750 cc. So initial finding. Initially, volume was 750 cc. So V1 is 750 cc. At minus 23 degrees Celsius, initial temperature was minus 23 degrees Celsius. Change the Celsius to Kelvin. Minus 23 plus 273. That will give you 250 Kelvin. And 800 millimeter pressure. Pressure initially was 800 millimeter. Three things you know. Volume 750. Temperature was so much, which I changed to 250 in Kelvin. And pressure is 800 millimeters. Okay. Question is, calculate the pressure. So in the second case, you are going to calculate the pressure. P2 is not known, for which its volume will be 720 cc. Volume 2 is 720 cc in the second case. The temperature being minus 3 degrees Celsius. In the second case, temperature T2 is minus 3 degrees Celsius. Change this to Kelvin. Minus 3 plus 273. That will give you 270 Kelvin. So, 3 quantities you know here. 2 quantities you know here, and you have to find the third one from here. Okay. So, according to gas equation, this is gas equation. P1 V1 by T1 is equal to P2 V2 by T2. Substitute the values. P1 800 into V1 is 750 divided by T1 is 250 is equal to P2 not known, so P2 into V2 is 720 divided by T2 is 270. Keep the P2, that's the unknown value, shift these numbers this side. So P2 is here, 800 is on the left side into 750, the 270 comes up into 270 divided by 250 was already there, and the 720 comes this side into 720 equals P2. To simplify this, you can cancel this with this. 250 goes once, 750 goes thrice. Then you can cancel this 0 and this 0, and then you can divide both of them by 9. 9 3s 27. 9 8s are 72. 8 and this can be divided 100 times. So you are left with nothing in the denominator. 3 into 3 is 9. 9 into 100 is 900. We are finding pressure. So check. Pressure originally was in millimeters. So the final pressure is also in millimeter. That's 900 millimeter. Okay. Next question. The pressure of 1 mole of gas at STP. Look at this word STP is there. Standard temperature and pressure is double, and the temperature is raised to 546 Kelvin. What is the final volume of the gas? Okay. the pressure of 1 mole of gas at STP is doubled. What is doubled? Is pressure is doubled. Okay. And the temperature is raised to 546. What is the final volume of the gas? There's something given in the brackets. 1 mole of a gas occupies a volume of 22.4 liters at STP. At STP, the volume occupied by 1 mole of the gas is 22.4 liters. This 22.4 liters is the volume occupied. Okay. So, pressure in the first case is not known, so P1 I have taken as P1 itself. Temperature in the first case, if you see, this is at STP, which means temperature is 273 Kelvin, 0 degrees Celsius. I said at STP temperature is standard temperature is 0 degrees Celsius, otherwise 273 Kelvin. Okay. So T1 is 273 Kelvin because it is at STP. Okay. Then volume 1, volume occupied, this is at STP, sorry, 1 mole at STP. At STP, volume occupied is 22.4 liters. Volume 1 is 22.4 liters. About the final values, the pressure of this is doubled. Original pressure was P1, now the pressure in the second case is doubled. Double means 2 times. 2 times of the original pressure, 2 into P1. And the temperature is raised to 546. The second temperature is 546 Kelvin. Question is, what is the final volume? Final volume V2 is not known. So, we use the gas equation. According to gas equation, P1 V1 by T1 is equal to P2 V2 by T2. P1 into P1 is same. P1 into V1 is 22.4 liters divided by T1 is 273 equals P2's value is 2P1 into V2's value you don't know. So V2 divided by T2's value is 546. Okay. Now to simplify, see what all you can cancel. There is a P1 on both sides which can be cancelled. Okay. 546 and 273 can be divided by 273, that will go once, that will go twice. This 2 and this 2 will get cancelled. So all that is left on the left side is 22.4 and right side is V2. So V2 is equal to 22.4 liters. Okay. Volume in the previous case also was measured in liters. Therefore, in this case also it has to be measured in liters. Now, about the previous part and this part, I have not mentioned anything about the homework. The homework is given in your written work, okay, in the assignment. Please check the homework, and about the page numbers which are there in the book, about the questions which you require, I will post it in the WhatsApp group.